Hi, my name is Kyle, and today we will be discussing Versa SSE site-to-site tunnel automation. First, let's define the use case. Organizations are increasingly turning to SASE, Secure Access, Secure Edge, to support a distributed hybrid workforce, increased use of cloud services, and a heightened threat environment. SASE is the combination of SD-WAN and Secure Service Edge, or SSE, and as can be seen in this diagram, Versa Unified SASE delivers converged network security with software-defined WAN in a single stack software solution. Versa's single pass architecture and single pane of glass management platform simplifies SASE deployment while delivering unparalleled network and security performance. When enterprises use Versa's unified SASE solution, there is no requirement to manually build site-to-site tunnels, as the SD-WAN and SSE environments share common built-in overlay connectivity. The use case the automation in this video will address is when Versa Unified SASE is not used by the enterprise, only Versa SSE leveraging Versa Cloud gateways. On-premise WAN connectivity in this case may be hosted by a service provider or the enterprise directly. This WAN connectivity may be Versa SD-WAN or connectivity on another vendor platform. Site-to-site tunnels are required to connect the on-premise environment to the Versa Cloud-hosted gateways. For Versa gateways, these site-to-site tunnels can be configured directly using the Versa Management Platform or Concerto. However, some customers may like to automate and standardize tunnel configuration using Versa's full set of RESTful APIs. To assist our customers on their automation journey, Swagger API documentation is built into the Versa Management Platform, or Concerto. To access the Swagger documentation, log into Concerto, click the drop-down in the top right corner by your username, and select API documentation. Alternatively, the Swagger documentation page can be accessed via the URL on the screen. If using the URL, the user must have already logged in successfully to Concerto. Once logged in, the Swagger API library will appear. There are a few prerequisites that are required to access Versa API. These prerequisites are listed here. If the Versa cloud-hosted solution is being used, the prerequisites can be coordinated with Versa support. If the solution is not Versa cloud-hosted solution, the prerequisites can be coordinated with the service provider hosting the environment. Creating a single site-to-site tunnel via API has three basic required steps. Run a POST API to secure an OAuth token, run a POST API to configure the site-to-site tunnel, and finally run a PUT API to publish the configuration to the Versa gateway. To perform the configuration in 3 steps, the tenant and gateway UUID must be known. For the purposes of this video, we will add 2 additional steps, assuming that the tenant UUID and gateway UUID are not known and must be queried. We will add those steps between OAuth token POST request and the site-to-site tunnel POST request, as shown in this process diagram. Let's check Swagger to identify the API call required to secure the OAuth token. In Swagger, I will do a find for OAuth and expand the OAuth section. Here we see 3 APIs. The API used to secure the OAuth token is the third on the list. When that section is expanded, we can see the POST API call and the required JSON body. For demonstration purposes, screenshots from the Postman app will be used in this video. The POST API call is run to the API seen in Swagger. Please note the portal API is added to the URL. The Concerto URL variable will be either the URL for Concerto or an API gateway. If Versa Cloud hosted, the URL would be for an API gateway. The JSON body contains variables from the body information provided by Swagger. When the API call is run, the OAuth token is listed as access token in the JSON response. This token will be used to authenticate remaining API calls. Next, we need to identify the API call for tenant UUID. As mentioned previously, if this information is known, then these steps are not required. And Swagger will do a find for tenant entity. Under tenant entity, there are a few API call options that can be used. For our case, we will use the get API to get the tenant information by name. There is no body for this get API call. The tenant's name is added to the URL. Now let's search for gateway to identify the API needed for our gateway UUID. We would like the SASE gateway controller section, and we would like to query the gateways. When we expand the query, we will see the need for the tenant UUID we received from the previous tenant API call to make this get API call. Taking a look at the API calls run in Postman, we see that when we add the tenant name to the tenant get API call, we get the UUID in the response. We then add the tenant UUID to the gateway get API call, and the response will include the names and UUIDs of all the gateways configured for the tenant. The UUID for the gateway will be used later in the publish put API call. We go back to Swagger to identify the API call and JSON body required to configure site-to-site tunnels. As we want to create a new tunnel, we will expand the post create API section where the required JSON body can be found. The Postman screenshots show we are again using the tenant UUID in the post API call, have included the body, and have received a 201 created response. As would be expected, the JSON body required to create the site-to-site tunnel is extensive considering the available parameters. In addition to the JSON body information provided by Swagger, the JSON body on the previous slide can be used along with this table to identify the data required. Please pause the video and screenshot this for reference. The configuration now must be published to the respective gateway, and the API call can be found in Swagger. If we return to the SSE Gateway Controller section, we will see the put API to publish the gateway configuration along with the required JSON body. In the Postman screenshots, we see that the tenant UUID is again used. The body includes the gateway name and gateway UUID we identified earlier, and the publish received the 200 OK response. Opening Versa Concerto, we can see that the tunnel has been created and the configuration has been published successfully. The API calls identified to configure and publish the site-to-site tunnels can be used to configure multiple site-to-site tunnels, allowing for scalability and standardization. One such Python-based automation effort example can be found on Versa's publicly available GitLab page. This automation can be downloaded and used by our customers, as well as fine-tuned for the customer environment. Please note that this automation is use at your own risk and should be fully tested prior to using in any production environment. On the screen, you can see the URL and files that are included. Download the files and make sure to reference the README file. In this video, we will run the script in a Versa-hosted environment. This flowchart displays the process that will be performed by the automation script. While the process may appear more extensive than the 5 API call approach covered earlier, the API calls are pretty much the same. The additional process allows us to easily generate variables for those API calls. The process starts with a basic CSV file that is filled in prior to running the script. Questions are asked to determine user access information, and access is granted. The gateway, customer VPN, tunnel type, tunnel parameters, and routing are then determined by answering displayed questions. The script then runs, and the site-to-site tunnels are configured. As depicted in the process flow on the previous slide, we will use a basic CSV file as a dataset. The fields can be seen on this slide. The device name and device template field are assuming a customer or provider-managed Versa SD-WAN deployment. From the Concerto perspective, these columns will only be used for tunnel naming purposes. Columns C through F are the on-premise router information. Columns G through H are for the Versa Cloud Gateway information. Let's go through an API-based multi-tunnel configuration. This configuration will be for an IPsec tunnel running BGP with the Cloud Gateway. At the top of the screen is the CSV file we will use. The name of the CSV file is entered by the user. The Concerto URL is entered by the user. The tenant name, client ID, client secret, username, and password are then provided. The OAuth token and tenant UUID are then received. Now that we have an OAuth token and tenant UUID, a list of tenant configured gateways will be displayed. The user then will enter a gateway name from the list. A list of available VPNs will then be displayed, and the user will enter a VPN from the list. The user is then asked to select the tunnel type to be configured. In our case, the tunnel type is IPsec. The list of IKE and IPsec parameters are listed, and the user is asked if the default or custom parameters should be used. Please note these default parameters are for demonstration purposes and can be changed in the script itself or adjusted by choosing to create custom parameters while running the script. In this case, we will use the default parameters. The user is then asked if dynamic routing will be used. In our case, we are using dynamic routing without a BGP password. The user is then asked if BGP import and export policies should be configured. In our case, we will say yes to policy configuration, and a list of configured policies will be displayed. We will enter an import and export policy from the list. The Concerto configuration then begins. The script will now start the gateway publish process and connect to the publish stream. The same publish stream that is seen in Concerto will be displayed with the final message being that publication is complete. The log files will also be generated for reference, should there be any issues with publishing the configuration. Additionally, there is a script that can be run on an on-premise director available as part of the same GitLab repository. To be conscious of time, the director script will not be demonstrated in this video. However, the process used is displayed here. Please note the script creates tunnels in the branch LAN-VR, expects concerto automation to be run prior, and uses some variables identified in the concerto script. This video has presented basic and multiple site-to-site tunnel automation possibilities with the Versa SASE solution. I hope this has been informative. Thank you for your time.